This podcast will focus on 3 amino acids: alanine, glutamate, and aspartate, and the carbon skeleton they produce during their catabolism. The rationale for focusing on these 3 amino acids, alanine, glutamate, and aspartate, is that they are substrates for 3 important enzymes: ALT, glutamate dehydrogenase, and AST. In addition, the metabolism of these 3 amino acids directly or indirectly can provide the nitrogens that feed into the urea cycle. And as such, they play a key role in overall amino acid catabolism and disposal of nitrogen through the urea cycle. The first amino acid is alanine, and it can be metabolized by alanine transaminase or alanine aminotransferase to form the carbon skeleton pyruvate through this reaction. And the ALT reaction simply takes the amine group from alanine, transfers it to alpha ketoglutarate as a carbon skeleton, and converts alpha ketoglutarate to glutamate. What is left of alanine is the carbon skeleton pyruvate. Importantly, the ALT reaction is reversible. It can go either way, from alanine to glutamate or from glutamate to alanine. It requires vitamin B6 or pyridoxal phosphate as a coenzyme. The second amino acid is glutamate, and the carbon skeleton derived from glutamate is alpha ketoglutarate. Glutamate can be metabolized in one of 3 distinct ways: by either ALT, by AST, or by glutamate dehydrogenase. Through the ALT reaction, glutamate can be used to make alanine from pyruvate. And through the AST reaction, glutamate can be used to make aspartate from oxaloacetate. And through the glutamate dehydrogenase reaction, glutamate can be broken down into alpha ketoglutarate and ammonia. The third amino acid is aspartate, and the carbon skeleton it produces when it is metabolized is oxaloacetate. It can also be made from oxaloacetate with glutamate as the donor of the amine group in the AST reaction. There are 2 noteworthy points to make about these 3 amino acids and the ALT, AST, and glutamate dehydrogenase reactions. The first one is that all 3 enzymes mentioned are reversible, and they can go in either direction. As such, they can be used to break down these 3 amino acids, or alternatively to resynthesize these amino acids from their respective carbon skeletons. The second important point is to note the role of glutamate. Glutamate serves as the sink for amines coming from several amino acids including alanine, and glutamate metabolism through glutamate dehydrogenase provides one of the two nitrogens that can enter the urea cycle, the ammonia molecule. Through the AST reaction, glutamate can provide the second molecule, aspartate, that can enter the urea cycle. The latter two nitrogen sources, ammonia and aspartates, are the only two forms of nitrogen that can enter the urea cycle. If you like this video, please subscribe. Thank you.